Yes, welcome back again. Now I am going to solve some theoretical problems in similar triangles. That too, first I think basic proportionality theorem. In that we will be doing only theoretical problems. Numerical problems we will be doing in the next class. So this is something little bit difficult, but if you know the previous theorems, then it will become very easy. So earlier part you have discussed basic proportionality theorem, converse of basic proportionality theorem, next internal bisector theorem, and areas of similar triangles. Various theorems I have proved. Now we are doing exercises of theoretical problems, not numerical problems. Let me begin. The very first class of theoretical problems, similar triangles, 10th, Cbse, state and Icse. Using basic proportionality theorem, prove that the line drawn from the midpoint of one side of a triangle, you have to use basic proportionality theorem is saying, prove that the line drawn from the midpoint of one side of a triangle parallel to the other side bisects the third side. What is given? Prove that the line drawn from the midpoint of one side of a triangle P prove that the line drawn from the midpoint of one side of a triangle parallel to the other side bisects the third side. Very simple, students. Here P is the midpoint given. Given P is the midpoint. That means, that is what the meaning, AB is equal to PB. And also this line is parallel to this. Let's mark this as Q. L is parallel to BC. Using basic proportionality theorem. What is basic proportionality theorem? If a line is drawn parallel to one side of a triangle, then it will divide the other two sides in the same ratio. Already given this line is parallel to this in the given question. Now, therefore, by basic proportionality theorem, AP by BP is equal to AQ by QC. But AP length is PB, both are same. 1 is equal to AQ by QC. AQ is equal to QC. Now this is becoming the midpoint. Why I got 1? Because here it is given no midpoint. Therefore AQ by QC. That means already. Now come back to this. Bisects the third side. It is bisecting the third side now. Finished. The very first problem is finished. Prove that the line is drawn parallel to one side of a triangle and only P is the midpoint given. Now he is asking, prove that Q is the midpoint. Simple. I use AP, basic proportional theorem, AP by PB, because this line is parallel to this one, but AP by PB is nothing but 1 is equal to AQ by QC. Now AQ is equal to QC, that means Q is the midpoint. AQ is equal to QC, that means Q is the midpoint. Q is the midpoint of AC. That's it. Next, another problem. Using the converse of basic proportional theorem, prove that the line joining the midpoints of two sides of a triangle is parallel to the third side. Here already given P is the midpoint, Q is the midpoint. Prove that the line joining the midpoints of two sides of a triangle. This one, P and Q are the midpoints of two sides of a triangle. Then you have to prove that this line is parallel to this one. Simple student. Nothing confusion. AP now since P and Q are the midpoints given, AP by BP is nothing but AQ by QC. Why? Why AP by BP is nothing but AQ by QC? Because AP, let us take this as 5, 5. Let us take this as 7, 7. Because P is the midpoint given, Q is the midpoint. Take the ratio 5 by 1, 7 by 7. It is always 1. Now AP by BB is equal to AQ by QC. Since P and Q are midpoints. Now both are equal to, therefore AP by BP is equal to AQ by QC, both are equal to 1. The ratio is 1. Now what is the converse of basic proportional theorem? If a line divides the other two sides in the same ratio, then that line is parallel to this one. By converse of dpt, the ratio is same. AB by BB is equal to AQ by QC. Then that line is parallel to the third side. Therefore, by converse of the equivalent, PQ is parallel to BC. Finished. Very simple. Once again, already given P is the midpoint, Q is the midpoint. That means AB by BP is equal to AQ by QC. But this is nothing but 1. Why? Because P and Q are the midpoints. By converse of basic proportionality, they are dividing in the same ratio. That means that line is parallel to that side. Next one. So I am teaching a little bit fast because your basics must be perfect by this time. And there are so many exercise problems are there. After this numerical problems we should do. That's why I am teaching a little bit fast. Please write down your comments and your suggestions. We will work as a unit. I will take those comments in a positive way and let us work as a family. Next. Prove that any line parallel to parallel sides of a trapezium divide the non-parallel sides proportionally. Very, very important. Prove that any line parallel to parallel sides of a trapezium. I will read out the question. Prove that any line parallel to parallel sides of a trapezium. Any line parallel to parallel sides of in trapezium, one pair of opposite sides are parallel. This is a line N parallel to. Prove that any line parallel to parallel sides divides the non-parallel sides proportionally. Prove that any line parallel to parallel sides of a trapezium divides the non-parallel sides. Which are the non-parallel sides? AD and PC are the non-parallel sides. Divide the non-parallel sides proportionally. What is the meaning of this? dP by PA is equal to CQ by DQ. This is the line parallel to this one. Now we have to prove that non-parallel sides are proportional. That means dP by P is equal to CQ by Q. Very simple, students. Join this. O. Next, draw BQ, join BQ and mark it as O. So already given this is parallel to this. Consider triangle DAB. DAB. PO is parallel to AB because already given, no? Given. So what is the meaning of this? I am taking this triangle. PO is parallel. Next, use BPT, basic proportionality theorem. What does it state? PD by PA is equal to OD by OB, right? I use basic proportionality theorem. If a line is drawn parallel to one side of a triangle, then it will divide the other two sides in the same ratio. Next, consider triangle VDC. Consider triangle. Now this triangle you consider. What you have to do? This line is parallel to this one. This is what I am saying. This triangle. What can you say? OD by OB. Next, you can write OQ is parallel to CD. This line is parallel to CD, already given. Now this is nothing but OD by OB is equal to CQ by DQ. Just concentrate on this part. OD by OQ, basic proportional theorem. CQ by QB. Next, mark this as 1, mark this as 2. PD by PA is equal to, what is OD by DB is equal to OD by OB, but this is nothing but what we got, CQ by DQ. Now PD by PA is equal to CQ by DQ. Therefore, it is dividing the non-parallel. Hence the theorem. It is dividing the non-parallel sides in the same proportion. That's it. Next one. Prove that the diagonals of a trapezium divide each other proportionally. Diagonals of a trapezium divide each other proportionally. A, B, C, D. Diagonals of a trapezium prove that diagonals of a trapezium divide each other proportionally. That means what you have to do is DO by OB is equal to, I started with here, so you need to do like this, CO by OA. What you have to do is construction, draw OP parallel to AB. Proof. What I am saying is draw OP parallel to AB. Now what, keep it in mind what you have to do. DO by OB. DO by OB is nothing but CO by OA. I will consider this triangle. Consider triangle DAB. OP is parallel to AB. Use basic proportional theorem. If a line is drawn parallel to one side, then it will divide the other two sides in the same ratio. DP by PA is equal to DO by OB. Right? DP by PA is equal to DO by OB. Now, consider triangle DAC. Now you consider this triangle DAC. What is the basic proportion of this line? Okay, one more example. One more is OP is parallel to AB. OP is parallel to AB. You know that in a trapezium, one pair of opposite sides are parallel. OB is parallel to AB. What does it mean? AB is parallel to CD. Trapezium. Then AB is parallel to CD means what? Then this is parallel to this one. Therefore, OP is parallel to CD. This is parallel to this one, but this is parallel to this one. That means this is parallel to this one. So once again, this line is parallel to this one, right? In trapezium property, what is that? One pair of opposite sides are parallel. That means this line is parallel to this one. If this line is parallel to this one, that means this line is parallel to this one. Therefore, mark this as 1. And OP is parallel to AB. AB is parallel to CD. That means clubbing 1 and 2, OP is parallel to CD. Now use basic proportionality theorem. We have proved that this line is parallel to this. Earlier in construction we have written this line is parallel to this, but now this line is parallel to this by these properties. Therefore, use the basic proportionality theorem for this triangle. dP by PA is equal to OC by OA. Mark this as 1, mark this as 2. dP by PA is nothing but OD by OB. In place of this, what you should write from 1 and 2? dP by PA is nothing but OC by OA is equal to, on this, is equal to OD by OB. From here you can write 1, here you can write 2, 3, here you can write 4. From 1 and 4, OC by OA, OC by OA is equal to this one, already approved. Right. See here, OC by OA is nothing but OD by OB. So this is how you have to do theoretical problems. Simple, very easy. In the coming classes we will be doing some more problems. And please share with your friends. Have a nice day. Thank you. Bye.